Okay, so I'm glad I heard Renaud made a few introductory statements which were good about process data. And I will be speaking mainly about how we have improved data processing and also process data. But first of all, I want to thank the people who did all the work. So I'm the speaker, but these are the real workers. The ones that are in bold, those are only the 3 positions of people that were financed. So we were lucky to get 3 COD positions financed by Streamline to work on this part, the software part of WP4. And all the other people are permanent staff who were involved. So again, we see the advantage of having a small amount of what I call seed money, and then being able to use our internal, the fact that we aligned the objectives of what we were doing in Streamline with the people that we have already at the ESRF. I did have an alternative title because I started to give a better title, and it's I found the best picture I could of an Ewoks and a cat. So these are the 2 keywords, the 2 softwares that we heavily based our work on, and I leave the rest of the cats to Joanne because she has a lot of cats. I only have one. Yeah. And I also put the word revolution in the title. And for me, the definition of a revolution is what is the impact of it. So often a revolution happens over a short period of time. And the one when I think of the French Revolution, which is a very sort of famous picture of representing what was happening. I mean, historians sort of agree that the French Revolution wasn't such a great success at the end because then Napoleon came back and things changed. It didn't actually go on like that, but the influence in Europe was huge. Yeah? So there was a lot of change and a lot of, let's say, ideas were spread around Europe, to Italy, to Switzerland, to Germany. And I'm hoping to convince you that what we did in Streamline in WP4 is going to have a lasting impact at the ESRF and maybe beyond as well. I always find this picture interesting. I don't know if you know, but that they say the French Revolution started actually at the Chateau de Vizille. So this is a painting which was done afterwards in the Jeu de Paume at the Chateau de Vizille, where in 1788, they started already and got together and started organizing themselves, the people, let's say the bourgeoisie, to get rid of the king, which happened in the real revolution happened in Paris in 1789. And I think the picture was what we did in Streamline software was more like what's on the right-hand side, where we were talking to the Beamline scientists. We were not like on the left-hand side. There wasn't blood and sweat and tears and that. Okay, so I always find it useful to go back to what we actually said we were going to do to see how close we actually got to that. And I think the most important statement here was that we wanted to go beyond just data acquisition. And I'll try and show you that. We had very clear objectives for the software part. The hardware part will be covered by Thanos and Enyo. We already knew in the beginning, I think we wrote this in 2018. I don't know, I actually forget when we started this idea of Streamline. Ed is not here. I don't know. Gary, do you remember when we wrote the proposal? 19, was it? Yeah. So we knew we wanted to get more into the workflow part, the sample tracking part, providing data analysis across all ESRF beamlines, if we could, which was very ambitious, of course, and to enhance what we were doing in terms of data collection and start looking into machine learning and artificial intelligence. And when we wanted a new mailing service, which would be valid for all beamlines, because we were doing mailing actually at that moment only for the MX beamlines. And the real revolution, I would say, what's the core of what we worked on was dealing with process data. So we've automated how data can be processed. And you'll see we've done that on a large scale. It's not finished, of course. It's only went on for 4 years, but we did a lot. Yeah? And I think this is what's going to change in terms of the ESRF. Yeah. And of course, we're not the only ones looking into this. This is a study from the National Academy of Sciences in the US. The Americans are copying us. No, I'm only joking. This is a common idea. You want to accelerate discovery or knowledge making. And one of the ways that's been pushed a lot in science is to go using automation of workflows. And of course, one of the ideas behind that is to bring machines and humans closer together. In our case, you'll see that we haven't really got so many machines in the loop. So everyone's dreaming of this, or you hear a lot about this on the news. Machine and artificial intelligence will change a lot, but we're still in the humans in the loop part. And I think that already is important. And if you go further into this document, you'll see you need all of these things. You need teams of people who are proficient in all these different areas to actually do this in a way which is structured and which you can, let's say, have something which you can apply on a larger scale. And in our case, if you look at all the team experts that we have there, we can rely on, of course, in the end, we're doing it for the users, but we can rely on the Beamline scientists as domain scientists or specialists. The users are that too. The data scientists in ADA, software engineers in BCU, data automation and visualization engineers in DAU, data managers, and of course, the IT engineers who provide all of the IT infrastructure. So you can see it's a complex setup, and a lot of people have to work together. Then if I get into what we actually did, so one of the first things we did, and this was precipitated by the COVID-19, which happened just like overnight. I actually didn't even believe when they said go home that we'd be off for we'd be locked down for, I don't know, 4 months or 6 months. It was only Pablo who said, yeah, don't worry, you won't come back for 6 months. And I really couldn't believe that. Anyway, it pushed us into, it was a very strong, because we were planning on bringing up the EBS during 2020. And then the priority on mail-in for all beamlines became very high and almost essential, I'd say. So this was then started in April, and we had a first version, which is still used today, by August. So, you know, every time I put a exclamation mark there, it's because I'm impressed by what my own people, or let's say the own people in my group can do, yeah. Now what we've worked on following that with a bit less time pressure was to unify everything so that we have the same mailing procedure for MX as we have for all the other beamlines. And this is the part that I will show a bit later in some slides, which we'll go through very quickly. Just to give you a feeling of this, because there's always a lot of work behind this, this shows you the workflow, which was worked out with the user office, with the safety group, with the beamlines, with stores. All of this was worked out in a very short time, everyone working remotely and implemented, so that I think today, I mean, these are the statistics I took yesterday. Already 1,929 parcels, 1,929 parcels were shipped, and you can just see a profile of which beamlines are actually using this the most. I don't know why, but it seems like ID1 is the main user of mail-in, I mean ID2, yeah, ID2, yeah. But there's some reason, I presume, for this. But you can see that this, even after the COVID, because after COVID, like in 2021, I think we had 800 parcels shipped. So this has continued, and this will continue as well. Now what we've done is we've unified the two interfaces between non-MX and MX. So I give you a few screenshots which show you this is the kind of interface that the users will see, because this is brand new work, or it's been going on since under the banner of Streamline. We haven't released it yet to users, but it's ready to be released after some more feedback. One thing that was requested, for instance, for the ID31 case, but also for other beamlines, is when you're bringing hundreds of samples, you want to be able to declare them with using your own tools and then import a file. This has been prepared so that you can import a large number of samples in an efficient way. One of the things that was specific to ICE-BY-B in the past was you needed to prepare the sample changer. So you have these dewars with the pucks in them. All of this is now implemented as well in the unified sample preparation part. And you can drag and drop your samples from onto the pucks and just ship them off so that when they come here, they can be immediately imported into MX Cube, and then you can do the experiment. The other thing that came from ICE-by-B as well was preparing what's called the experiment plan and the processing plan. So if you look at this over here, this is a pointer, yes. So here you can see the experiment for the experiment plan, how many, what you want to set up. And then for the processing, you can say which pipelines you want to set up as well. And all of this that we've developed now is available, was previously only for macromolecular crystallography, is now available for all techniques. So you could imagine configuring this to be a different kind of processing pipeline. Yeah? I don't know what the smiles are. I'm sure you can. Why? How many smiles do you need to do an MX experiment? Yeah. So ICE-by-B was for 20 years. So it was what we call the LIM system, was developed for MX and was originally developed here at ESRF, but then exported to other facilities and has become a European and even international collaboration. When we wanted to unify everything, we realized that this actually was too, for us, too MX specific, and to extend that to suit all techniques would be more work than taking a generic solution, which we had also on site called ICAT, and making that work also for MX. So this is really I'd say one of the major results of Streamline, is that we had the resources which allowed us to do this. We also had the motivation because we wanted to unify things. And I think the huge step forward for all techniques is that they can now, we don't have the separation between MX and non-MX anymore. And we can imagine certain techniques, of course not all techniques, will evolve into more sophisticated, automated type of experiments. Just to show you what you can do with this new, with the new interface, this is an open data set, which you can go and afterwards in the slides, click on here and play around with this. You can display any kind of result. These are the results which were specified by the structural biology group, and we're very grateful that they were so motivated to help us set this up. But you could imagine displaying data from tomography, from other techniques. We just need to know from the scientists, what do they want to see? One thing which, with this new display, it also opened up the possibilities to do kinds of displays of process data we couldn't do previously or hadn't done in ICE-by-B. Here we have multiple data sets which are merged together at the end. So they were taken at different positions on the crystal over here. And then the results are merged together using processing software, and they are shown as a single data set at the end. Yeah? And this was something that's been requested by the community and the scientists for a long time. Yeah? We were, one of our biggest, let's say, targets was to implement everything for zero crystallography. And we actually did all of the interfaces, but we didn't have enough manpower to do the data processing online as well. So at the moment, we're just waiting for this to happen this year still. There's a small delay in this part. So now to come to the workflows. Why are we doing workflows? The way we see this actually is that from the beginning of the ESRF until the end of the first machine, we were basically producing data, and then the problem was left, raw data was given to the users, often on USB disks, or and they went away with it. And until 2015, there was no engagement even to store that data for a long time. So almost all public experiments, the data was deleted. Depending on how much space was still available on the file system, they were deleted after a certain number of months. And there was no record of it. When we introduced the first data policy, we then said we will keep this data for at least 10 years. Of course, assuming we can still afford it, but our goal is to keep it for 10 years. And last year, we also updated the data policy so that we said we will include process data as well. And now we come back to what we can now say, that our aim is to provide process data to users. And the goal of all this workflow work is to also produce results which you can give to users. And this all fits in with the current trend of doing open science and making data fairer. And as it ties up with what you said, the long delay between publishing, or between taking the data and publishing, this is still in many cases longer than one would like it to have. And maybe we also don't have a statistic on how many experiments don't publish at all. And so what we think is that working on giving users results while they at the end of the experiment will hopefully reduce this delay and hopefully increase the number of publications. And why we say this is because of prior to EWOX, prior to Streamline, people would come here, do their first experiment, go away, think a bit, do some analysis, come back with a new idea, do a second experiment, finally analyze it and publish. This could take years. Yeah? And also if we have new users, they might get stuck at one of these points as well. So the idea of doing all of this during the experiment or as soon as possible is that they can stay here in this, get this feedback immediately, that they can then already prepare the data where they can do a publication quicker. And for this, the things that we see they need are visualization, getting results which speak to them in terms of the domain, scientific domain, and integrating that into the data acquisition. So before Streamline, there were certain, let's say, niches where people were actually doing this. And I mean, structural biology was often cited as this is an example of how you can do things. But a lot of effort went into making that happen. And some people also said, well, we can't put that effort into every technique. And where people were doing things for them, let's say for their own scientific domain, they were not being shared amongst beamlines. So you had this, there was no way to scale what's called the economy of scale. There was no way to scale up so that you could do it in a generic approach. And to do this, what we said, okay, in Streamline is we needed to be able to make something which can run at the ESRF on our clusters, but also on the user's laptop. It can be rerun at any time to give the same result. It has to be accessible or modular in the sense it can be applied to multiple techniques. We want to support the fact that you're sitting at the beamline and doing this, or you at home, or you're running it on the cluster and it's running overnight without anyone sitting there. So all of these requirements said that afterwards, okay, the one thing we could do is we could develop or use existing workflow solutions which would allow us to do this, because this is sort of what workflows are made to do. I think what's been unique here, or very well done at as part of Streamline, is that all of the needs that were on this previous slide were taken into account so that they fitted to the beamline. So that we see today on the beamlines, this is running on half of the ESRF beamlines today. Because you have lots of workflow tools out there, and these workflow tools, I mean, we could say to the users, go and use workflow tool XYZ, but they would be on their own to get the data in there, to make sure all the metadata is there. To do it online is a much bigger challenge if the users are on their own. So by us doing this for them, I think it really makes it something that will sort of make the experiment much more, let's say, make it sure that this happens. Just to tell you where we were coming from, I mean, before EBS and also before Streamline, we had multiple different workflow solutions at the ESRF. And if you look at there are hundreds out there. This is just some of the more popular ones that are listed and are well known. But you know, there's been a lot of discussion which one you should use, which one is the best one, which one will be there for the longest. I mean, here's an example from SB. We were using a commercial tool called Passerelle. Our approach in the end was to have a more, what's called a more meta approach. Yeah? So we have what we call is a meta workflow system. Meta means it's at a level higher than the normal workflow. I think I once heard meta in Greek means table, or not? No, it doesn't. No? I'm not sure. No, you'll explain to me. But basically what we did is we came up with a common representation describing workflow in any of the systems that we had already. So we already had Orange, we already had the MX workflow system, and we had DASK. This representation works for all three of these. Then we developed an editor, which allowed us that people could edit them, their own workflows. And we had a way of triggering the workflows, either from Bliss or offline. And finally, we store all the results, we persist them all in HDF5. The actual workflow itself, so what we're calling automated execution, is starting a job, which will then go to the right workflow engine and say, please, well, run this workflow using this description. So everything that's on the left is actually very light. So this was developed in 6 months by someone who's very bright here. But it's now maintained by a group of people, and we can provide workflows in any of these systems to the different beamlines. And here's a typical example. This is one that comes from ID31, but one which is widely used on all the on many beamlines at the SRF is the, let's say, canonical example is to do the radial integration. Yeah, so radial integration means converting a 2D image into a 1D spectrum. You have to take into account a lot of things, and we have an excellent software for that called PyPhi. But actually, PyPhi was not running in an automated way on many beamlines. People were running PyPhi from their own scripts. What we managed to do is make PyPhi a kind of standard service on, I don't know, as many beamlines as are using PyPhi. There might not be a beamline yet that doesn't have this solution. Just to explain again what it does, and I think you might talk about, well, we'll hear about ID31 afterwards, is you convert this image over here, this 2D image, which is a powder diffraction pattern, into a 1D pattern, and this is displayed immediately in the data portal. So within a second or two, the users can see this result, and what the user said is, we want to see the diffractogram. This is what's called the diffractogram. And you saw from the previous example of MX, we can go much further in terms of visualization. We just have to know from the scientists what kind of software they want to run automatically. What's unique about EWOX, I think, because a lot of the tools either usually address only one of these aspects. They don't address all of these aspects. So we were really thinking it has to be easy to install and be able to be run on your laptop or run on a cluster or run from the web or run from a command line. And so we actually supported all of these. And these are just, I'll quickly go through these examples. This is what it looks like for what's called EST, which is for spectroscopy. For tomography, this is used, I think, on almost all the tomography beamlines to do an interactive reconstruction called Tomware. This is the web version. The web version is what you would expect it to be. You drag and drop things, and then you join them up with these lines. And once you're finished with it, you just say run, and you can submit this to a cluster if you want or not. So this is sort of opening the field also to scientists or users doing their own workflows. What we've also done, the same system is used to reprocess data so that scientists, especially the MX people, they wanted to be able to go and select certain images, which were the best ones, instead of the ones that were done with the initial analysis. They wanted to be able to let the user say, I want to use these images to do the processing, because these are the best ones. And this happens all now from the data portal, where you can select which images you want, and then you start an EWOX workflow. You can run it, people who need command line access or no GUIs at all can run it. People run it from Python directly, so from Bliss, you can call it directly as well. I think this slide, it says quite a lot. I think if you think that this was started, I think in 22, yes, and now we have it on 23 beamlines. So either in operation or currently still under development. Some of the developments, what we've addressed at the moment is what we call the basic workflows. It's called the low-hanging fruit. These are really the simple ones, like doing the radial integration. Users shouldn't be wasting time with that. It should be done in a robust, reproducible manner. The next level is to go to much more complex workflows. And we think the sky's the limit. There's a lot that can still be done. We already have a catalog of tasks, and anyone who wants to find out about EWOX can go to this website. I'm coming to the end, or almost. This is the, you remember in the objectives, we wanted to look into machine learning and AI. One person was hired for that, and he was limiting the scope to 1D 1D patterns. So what was done, and this was probably, he's told me this is Quentin Bruel, the most promising result came from identifying phases when you know what are the, you know what the sample is made of. So the way this works is that using a standard simulation software, you generate simulated patterns, and then the machine learning can go and the neural network will be trained on the simulated data to then recognize the percentage of the different elements in that in the sample. So yeah, this is a result where they took a powder diffraction map, but it's actually a cube. Every pixel is a 1D spectrum, and it could recognize all of the phases correctly. So it's promising, and I think this could end up being used more often on the beamlines. I don't have time for a demo. You can go and play with this on your own, so I won't spend any time on the demo here. We say there was a slide that what are the tangible outcomes? So for me, well, this is actually the conclusion, is a mail-in service, I think, for all beamlines. The new LIMS, which is now unifying all of the different techniques, the new data portal, the workflows that are running on 50% of the beamlines, and how we really feel confident we have a handle on handling any of these data processing challenges that are on all the beamlines. So, and I think this is I mean, for me, this is a big step compared to where we were in 2019. Yeah. And yes, process data can now, I think we can start saying we can offer process data. We still have to discuss. I personally, I think we have enough staff to do that. Yeah, but we have to discuss if this fits in with the mission of the ESRF and how far we want to go. We still got lots to do. As I said, we've only worked on the basic EWOX workflows. We have to finish all the beamlines and then go into the more complex ones. Continue, of course, with improving the metadata, like what we heard from Renaud. Part of Streamline was to actually, I didn't show the human organ atlas here. The first open data we had at ESRF since 2011 or 10 was the paleontology data. This is what Paul asked us to set up a website. This website is being replaced, and we're giving them DOIs so that you can track them. I heard yesterday that in this database, there are over 400 registered people over the last, since 2011. So over the last 13, 14 years, there has been interest in this data, and people want this data. I think, you know, this is a thing we can do. We want to go, this is what's promised to ID21, is he wants to run the full analysis or the full results during the experiment as a workflow. So there's a software that Wout wrote called SpectroCrunch, and this will produce these maps, which at the end will be for the user really the results. They can just then interpret it and publish it. Yeah. This is what we're working on together with Renaud, and everything's open source, available. Some of it's already running at Alba and HZB, Sesame as well. And okay, thanks to everyone again.